All right. So let's take a look at what you guys are coming up with. The first step, so, we learned these steps yesterday of how to factor quadratic trinomials that look like this. The first step is to multiply the coefficient of the x squared term, which is 3 on this problem, with the constant term, which is -5. So 3 times -5, that's going to give us -15. Okay, -15. And once you have that, then you now have this new looking quadratic trinomial that we can factor. And we're going to use the magic X for that. And so some of you are setting up your magic X, like right here. This person put -15 at the top and -2 at the bottom, which is perfect. That's exactly what you want to do. Okay, and we want whatever numbers we're going to come up with, they need to multiply and give us -15. And then at the bottom of this X, we have -2, so we want them to add and give us -2. 3 and -5, does that work? 3 times -5 is -15. 3 plus -5 is -2. So that is the correct pair of numbers that complete our magic X. And we can use those now to factor this trinomial into x plus 3 times x minus 5. All right, your third step is then to undo what we did in the first step. So because in that first step, we multiplied by 3, we're going to have to divide that 3 back out. Step 3, divide the 3 back out from both constants. Which means I'm going to put a division bar under the 3, because that's one of my constants. And divide by 3. And also under the other constant in the other binomial, I want to divide by 3 as well. So that's your next step here. This is undoing what we did at the start. The whole reason to do this at the start is just so we can use the magic X to factor. Okay, so we want to divide that 3 back out. Step 4 is to simplify both fractions. So when you're dividing this 3 out from these constant terms, that creates 2 fractions. And so now we want to simplify these 2 fractions. Sometimes they simplify to a whole number. Sometimes they simplify just to a fraction, or they don't simplify at all. And so for the first binomial, x plus 3 divided by 3, let's see, what did we get? What is 3 divided by 3? Anybody in here now? 3 divided by 3? What did you say? Huh? 1. Yeah, it's fun. So this is going to be rewritten as x plus 1. And for the second binomial, that fraction -5/3, There's no common factors in 5 and 3. It's an improper fraction, but that's okay. We're going to leave it just like that. So there's nothing we can change on that one. And we're almost done. We have one step left. Step 5. And this last step is why this method is called the bottom-up method, is that we bring any number left in the denominator or in the bottom, and we bring it up in front of the x term on both of these, okay? So any number that's left in the denominator, we bring up in front of the x term. So there's just this 3 that's left over in the denominator. So I circle it, and I'm going to bring it right here in front of the x. And then I will be finished factoring x plus 1 times 3x minus 5. This is one method of factoring a quadratic trinomial where your coefficient in front of the x term is not 1. And you can always check your answer by multiplying that out. You can FOIL it, or you multiply the first terms, the outside terms, the inside terms, and the last terms, and you would come back to the original polynomial that you started with. So we have these steps just a little bit further back. Okay, this is what we just did, all right? I try to put the steps on our warm-up today just because it's good to see those with a specific example being worked out. And we're going to keep doing this today, but we're going to kind of add on to this idea. So instead of just factoring an expression, we're going to solve an equation that has this expression in it. And so to do that, it's kind of like what we were doing on Tuesday. So on Tuesday, you were able to solve these by factoring and then setting each factor equal to 0 because of the zero product property. So we're going to do that again, all right? But we're also going to use what we just practiced in the warm-up and what we learned yesterday. So we're going to do one of these together step by step. So I'm going to move you guys forward to slide 9. We're going to do number 9 together. We have 5x squared plus 18x plus 9 equals 0. And so just like on Tuesday, when you solve an equation, you want to make sure one side is solved for 0. And that's also true with these. So that's already done for me, which is great. So I'm just going to move into looking at the left-hand side and trying to factor the expression on the left-hand side of this equation. I do notice that on the x term, my coefficient is not 1. My coefficient is 5. So I'm going to use the bottom-up method. I'm going to circle 5, and I'm going to multiply it with 9. What's 5 times 9? Type it in the chat, or you can say it if you're in the class. What's 5 times 9? 45. You're right. Thank you, Kron. So we're going to write this new polynomial as x squared plus 18x plus 45 equals 0. So the reason I multiplied 5 and 9 together is so that I could get something that's factorable with the magic x. This number here, this 45 is going to go up top. And then this 18 right here is going to go on the bottom of my x. And now I'm trying to think of two numbers such that if I multiply them, I get 45. But if I add them, I get 18. Let's see if anyone's coming up with these two numbers that we need. This person figured out 15 and 3. 15 times 3 is 45, and 15 plus 3 is 18. So 15 and 3 are the two magic numbers that we're going to use here. 15 and 3. So now that I've used my magic x, I can now write this expression factored. X plus 3 times x plus 15 is equal to 0. Doesn't matter which factor you write first. I could have also written x plus 15 times x plus 3. But now, because I'm using the bottom up method, I need to account for multiplying by 5 by then doing the opposite. So I'm going to divide 5 out of each constant in each binomial. We're going to divide 3 by 5 and 15 by 5. Now I want to simplify both fractions. So x plus 3/5 is going to stay as 3/5. And x plus 15 divided by 5, that simplifies to a whole number. What is 15 divided by 5? 3. All right. And then the last step of the bottom-up method is to look for any numbers left in a fraction in the denominator. There's a 5 here. So we're going to take it from the bottom and move it up. So we have now completely factored. We have 5x plus 3 times x plus 3 equals 0. Now, notice we have this equals 0 kind of tagging along all the way. And so what's new today from yesterday is that now I want to solve this equation. So if I have these two things in parentheses being multiplied together, and I know that their product is 0, by the 0 product property, one of them has to equal 0. So the next step here is to set them both equal to 0. We're going to write two separate equations. We have 5x plus 3 equals 0, or x plus 3 equals 0. All right, because they're multiplied together equals 0, so one of them has to be 0. Now I'm going to solve each of these. I'm going to subtract 3 from both sides on the first equation, which then gives me 5x equals -3. I'm going to divide both sides by 5. So for this first equation, x equals -3/5. For my second equation, I'm going to subtract 3 from both sides. X is equal to -3. So these are my two choices. Either x is equal to -3/5 or x is equal to -3. This is my answer. So you want to box your answer. It's a combination of both possible solutions of x. And you can even check those. If you were to replace the x up at the top in the original equation with either value of x here and then simplify it, you would get 0 equals 0 both times. So one of these is the solution. Do you have any questions right now on what we're doing so far? Caesar? Yeah. Does this make sense? Is there anything I could clarify? I know it's a lot happening, right? There's a lot of steps. We're going to do it the same process again with this other one, okay? We're going to use the bottom-up method to make it factorable. So then factor it. And then we're going to solve it by setting each factor equal to 0 and then getting 2 possible answers for the equation. All right, so we'll just go through it step by step. This is one of those things that the more you practice it, the easier you'll get. Okay, I know it's a lot of steps. I realize that. We're going to learn lots of different ways to factor. And this is just one method. All right, so we're going to look at number 10 now. We have 12x squared minus 36x plus 15 equals 0. So I want to use the bottom-up method. I might be able to make this problem a little bit easier number-wise to work with. You know, sometimes you would notice there is a GCF, a common factor. And, you know, I do happen to have one here because 12, 36, and 15, what number are they all divisible by? It's not necessary to divide out the GCF. It will help you a little bit with your calculations, but you would get the same answer either way. So just right up here, I'm going to just write something to help you see what the GCF is. I write 12 factored. It's the same as its prime factorization is 2 times 2 times 3, right? For 36, That's 2 times 2, which is then 3 times 3. 4 times 9 is 36. And 15th prime factorization is 3 times 5. So what number do all three numbers, what factor do all three numbers have in common? 3, yeah, so there's a 3 right here. There's a 3 here and 3 here. So sometimes if you do notice there's a GCF, you can divide it out right away and it'll make your work a little bit easier. So we can try that with this one. So I'm going to pull the 3 out. That leaves me with 4x squared minus 4 times 3 is 12, so 12x plus 5. That's equal to 0. And so, you know, right here, I think I could break this up. We have 2 factors. We have 3 as a factor, and we have everything in the parentheses as a factor. So you can even do the zero product property right now. Either 3 equals 0 or 4x squared minus 12x plus 5 equals 0. 3 equals 0, this is not going to happen. So you can just kind of forget about it. And we're just going to focus in on this right here. Our coefficient in front of the x squared term, it's still not 1, so we are going to use that bottom up method. We're going to circle the 4, multiply it with 5. My new trinomial now is x squared minus 12x plus 20 equals 0. And we can use this in the magic x. Put the 20 up top. Put the negative 12 in the bottom of the x. And try to come up with a couple numbers here that multiply to give us 20, but add to give us 12. I know 2 times 10 is 20. 2 plus 10 is 12. We actually have a negative 12. So I can use negative 2 and negative 10, because negative 2 plus negative 10 is negative 12. And negative 2 times negative 10 is positive 20. So these two numbers will work. So my factorization now is x minus 2 and x minus 10. That's equal to 0. And before I could set these equal to 0, because I multiplied by 4, I got to divide that 4 back out. So we are going to divide by 4 here. And divide by 4 here. We want to simplify these two fractions. So x minus 2/4. What does 2/4 simplify? What's a simpler fraction? Remember simplifying fractions? That's up here on the board. So you have a fraction, and you think of it as prime factors. 2 over 2 times 2. You have a pair of common factors, they divide out. And if everything divides out, then you're just left with a 1 and 2. So we do that. So we would get 1/2 or 2/4. And we would also get what? Negative 10/4. We're going to simplify that one. N's prime factorization is 2 times 5. 4 is 2 times 2. There are common factors. So the simplified version, it's still improper, but that's okay for this. Okay, so we simplified them, but now we need to bring anything left in the bottom up. So I can circle the 2 and bring it up here, circle this 2 and bring it up here. So my final factored form is 2x minus 1 times 2x minus 5 equals 0. And so when you have two things being multiplied together and it equals 0, that means one of them has to be equal to 0. So we will set each one equal to 0 separately. 2x minus 1 equals 0, or 2x minus 5 equals 0. Solving, add 1 to both sides. 2x equals 1. Divide both sides by 2. So x equals 1/2. Or over here, if I add 5 to both sides, 2x equals 5. Divide both sides by 2. X equals 5/2.